Okay, in this section, we're going to be looking at integrals that have exponential and logarithmic functions in them. We are going to start with something very easy. I say it's easy because we did this already. All right, so this is the review of the derivative of logarithm functions. So we know that the derivative, yes, ma'am.
You know the problem that you gave us yesterday? When you
Oh, I gave you a problem yesterday.
Yeah, you told us to try it.
Okay, let me see.
And I tried it and I didn't get it. So I want to know, can you go over it, please?
I certainly can. Substitution problem?
Yes.
It
was.
Oh, shoot. I know what the problem is. I'm in the wrong section. Okay, that's fine. Let me go to I'm in the master. I need to be here. Oh, that's right. Okay, so now I know what I'm doing wrong. Give me 1 second. The master, where is this? The master, I never copied this section over. Okay. Mover copy to section 2. Module 1, copy. Okay, now when I go to section 2, there it is. And this is the problem.
Yes.
Okay. All right, so let's do that first. All right. So for this problem, we're doing a U substitution. What's U going to be?
4x3.
Okay, so U is equal to 4x cubed. Good. And what is du?
12x squared.
12x squared what?
Dx.
Dx.
Then divide the 12 on both sides.
X squared dx. Okay. All right, so now on this side, I get the integral. I have, this is U. I think I was using a green for U. This is U. And then x squared dx is du. So this becomes the integral of the secant squared of u, and x squared dx becomes du over 12. Here is x squared dx. Okay. So this now becomes the integral, so 1 over 12, the integral of the secant squared of u du. So what's the integral of secant squared?
Tan x.
Tangent.
Tan u.
Over 12, the tan of u plus a constant. So the answer is 1 over 12. The tangent u was 4x cubed plus a constant. Ayana, who was that, you that asked the question or somebody else? Who asked that question?
I asked the question like I didn't understand it. I was lost. I got lost at the part where you divide du over 12. I didn't know what to do after that. So
do you know what to do now?
Yes. Thank you.
Okay. So you always want to make sure you're swapping out one thing for the other. When you're done, there should be no x's left. But you have to make sure you legally swap everything out. Okay?
Thank you.
You're so welcome. All righty. Okay, so integrals involving, uh-oh, that's the wrong section. We did that one already. What in the world am I looking at? I am thoroughly confused. Whoa, that's definitely the wrong class. Oh, I sent the wrong one already. There we go. This is the one. Okay. It is hard having two sections of this because I legally can't post a video from one section to another section. And there we go. We are set. All right, so like I said, we were doing logarithms. So let's go back and look at derivatives. So these are the derivative of our logarithm functions. Remember, we take the derivative of log x, we get 1 over x. The derivative of the log of u of x, we get 1 over u of x, but you have to multiply by the derivative of the function inside. Chain rule gives you du dx. And the derivative of natural log base a of x, you get 1 over x natural log of a. And the derivative of natural log base a of u of x gives you 1 over u of x natural log of a times du dx. So these are our basic derivatives, and we need to understand derivatives in order to do integrals, because that is the inverse function. So this is our integration rules for logarithms. The first is that when you do this has gotta go. The integral of 1 over x dx is the natural log of x plus c. And the integral of 1 over u du is the natural log of u plus c. Sometimes you will see this written as the integral of dx over x, the natural log of the absolute value of x plus c, and the integral of du over u. So they're the same, but it just looks a little different. It's the natural log of the absolute value of u plus a constant. So let me give you some examples. Okay. All righty. So the first one, okay. So you have the integral of 3x squared plus 2 over x cubed plus 2x minus 4. All right, so just looking at this, which term looks more difficult and more involved?
X to the third plus 2x minus 4.
Okay, so that's what I'm going to let u equal. And then I'm going to let du be its derivative, which is 3x squared plus 2. And that whole thing is dx, okay? 3x squared plus 2 dx. Okay. So then notice that this is still u. That's, oh, I think I was using green for you. I'm using that for, so this is u. And this whole thing, 3x squared plus 2 is multiplied by dx. Well, that's exactly what I have. 3x squared plus 2 is multiplied by dx. So this integral simply becomes the integral of 3x squared plus 2 is just du. And then x cubed plus 2x minus 4 just becomes u. Well, that's easy. That's the natural log of the absolute value of u plus a constant. So that means my answer is the natural log of the absolute value of x cubed plus 2x minus 4 plus c. Okay, any questions about that?
Could we do another example?
Oh, God. I have several. I would never leave you hanging with one example. Okay. Let's say we have integral of e to the x divided by 1 plus 2 e to the x dx. What would you do?
So the u would be plus 2 e to the x.
Okay. All right, and then du.
Oh. The one would fall off, but the 2 would that fall off as well?
You tell me.
Is it 2x e to the x?
It would be 2x. I'm sorry, it would just be 2e to the x. No other x is equal. Just 2 e to the x.
Thank you.
And then what am I missing?
dx.
dx.
Mhm. Okay. So in my problem here, I have 1 plus e to the 2x. That's u. And I have over here e to the x dx. Oh, e to the x dx. I have too much. So I'm going to divide both sides by 2. So I can just get the e to the x dx part. Everybody okay with that? I know some people don't like that dividing over here, but that's what I need to do. Okay, so now this is the integral. E to the x dx is du over 2. And 1 plus 2 e to the x is just u. So factor out the 1/2, and you get the integral of du over u. The whole purpose of this is to get it to look like something I know. All right, and the integral of du over u I know. So this is 1/2. And again, this is the natural log of the absolute value of u plus a constant. So this is 1/2 the natural log of 1 plus, oh, I can get rid of the, when you know the thing is positive, you can get rid of the absolute value. 1 plus 2 e to the x is always positive, plus a constant. I know it's always positive because e to the x is always positive, and 1 plus something positive is always positive. Okay, any questions?
So you're just dividing by 2 to make du look like the numerator?
Exactly. I need du. Well, it's not so much du needs to look like the numerator. Whatever's left in the problem is the only thing I can substitute out. So in the problem, I have e to the x dx. So I need to only be able to put e to the x dx back into the problem. I have 2 of them. And so the 2, that's too much. So in order to get just what's in the problem, I only want what I'm looking at. So in order to make a complete substitution from one thing to the next, it has to be perfect. And so I need e to the x dx. Over here, I have 2 e to the x dx. To get rid of the 2, I divide both sides. Now it's perfect.
Okay, that makes sense.
Okay. Okay, I have another one. This one's a little more different. It's a little challenging, but I want you to work through it, and I'm going to take roll. So this is number 3. Don't worry, don't worry. It's the integral let's see. When x is x is pi over 2. X is, okay. Pi over 2 to pi of 6 times the sine of theta divided by 1 minus 3 cosine theta d theta. All right, so let's get started. What is u?
1 minus 3 cosine theta.
Okay. And I'm gonna let you go from there. I'm going to start the attendance. Okay, who wants to give me this answer? Help me do this problem.
I could help part of it.
All right, Rodney, let's go.
So is the du, is that 3 sine theta?
Yes, it is. Beside theta, what?
D theta.
Oh, yeah, d
Okay.
theta.
All right, Rodney, what do I do next?
You have to divide by 3.
Okay. So I'm going to get sine theta, d theta is du over 3. Okay, good. Because if I rewrite this, I can put the 6 on the outside. I don't have to worry about that. So now I have sine theta d theta, which is what you found, what you solved for. And then 1 minus 3 cosine theta. So what else do I have to do now?
So
I got to deal with these.
oh yeah, we need to integrate.
Got to do with the limits of integration, right?
So we need to plug in
X is pi over 2.
yeah.
What is u?
Shit, I forgot.
1 minus, okay, here it is on top of it's right here. Rodney, right there. So if x is pi over 2, u is 1 minus 3
Oh shit,
cosine of pi over 2. You got it now?
Yeah, I got it. Okay.
Cosine of pi over 2 is 0. So you just get 1. Okay. And when x is pi, you get u is equal to 1 minus 3 times the cosine of pi. Cosine of pi is minus 1. So that gives you 1 minus a negative 3. So that's 4. All righty. So now my full transformation, Rodney. Do my full transformation.
Give me a second. Wait. I got lost. I'm sorry.
Okay, so let's refocus. Everything has to move, right? Okay, so start where it starts. So let's start with the limits. The 6 and 6 are good. When x is pi over 2, u is 1. Okay,
Mm-hmm.
so that means a 1 goes in that spot. When
Oh, and then
x is pi,
when pi is,
u is 4.
yeah.
So the 4 goes in that spot. Then sine theta d theta you already did for me. You said sine theta d theta is du over 3. And then,
Dr. Luck, I'm so sorry for interrupting, but can du over 3 be written the same way as 1/3 du?
yes, it is 1/3 du.
Okay, I just want to make it easier on my end for calculating.
Yep. Okay, and then 1 minus cosine of 3 theta. Uh-oh, there we go. That whole thing was just, oh, that was just u. Okay, so see how we took something very difficult? Look at the top problem. We took this and we now made it this, which is easy. Okay, because we're going to simplify. We're going to pull out the 1/3. So the 1/3 and the 6 make a 2. The integral of du over u, which is 2 times the natural log of u, but it has to be evaluated. And don't get it twisted. Okay, start from 1 to 4. Whatever the numbers are, that's the order they have to go in. So this is 2 times the natural log of 4 minus the natural log of 1. This is absolute value. Natural log of 1 is 0. So this is 2 times the natural log of 4. Okay. How we doing?
I got a question.
Yes.
Isn't -3 cosine pi 3?
Cosine of pi is -1. So I have 1 minus 3 times -1, which is 1 minus a -3, which is 4.
Oh, okay. I see what I did.
Okay. Anybody else? Need more help with that problem? Okay. All right, so now that we've done that, we are actually able to find the integral of tangent and cotangent. So we are going to use the fact that the tangent of x is the sine of x over the cosine of x. And the cotangent of x is the cosine of x over the sine of x. Okay, any questions about that? Those are just basic definitions. All righty. So the integral of the tangent of x dx is the integral. In the numerator, I have the sine of x. And in the denominator, I have the cosine of x dx. Now, we never want we never want du to be in the denominator. It can never be in the denominator. So if du can never be in the denominator, it has to be in the numerator. So therefore the u is what's in the denominator. So I'm going to let u equal cosine x. How nice is that? Du is equal to the sine of x dx. Something's wrong with that. Okay, so therefore this is u.
Wouldn't it be negative sine x?
Yes, it is. Thank you. Don't want me to write it on the paper. Okay, so sine of x dx is going to be negative du. So I need the sine of x dx. This is negative u du. Okay. So therefore, we get the integral sine of x dx is negative du. All right, that doesn't bother me. Cosine x, well, that's just u. How nice that is. So this is negative the integral of du over u. So that just gives me negative the integral of du over u is just natural log of u plus a constant. So this is the negative natural log of the absolute value. U was cosine x plus a constant. Okay, so that is what our answer looks like. The only problem is when we talk about calculus, functions have partners. So sine and cosine are partners, tangent and secant are partners, and cotangent and cosecant are partners. So therefore, we want to write this in terms of its partner. So this is the natural log of the absolute value of the cosine of x to the -1 plus c. But 1 over cosine is secant. So this is the natural log of the absolute value of secant of x plus a constant. So we get the following two rules. The first one is that the tangent, the integral of the tangent of x dx is negative. I'm sorry, no, it's not. It's positive. It's the natural log of the absolute value of the secant of x plus a constant. And if I do the same thing with cotangent, I'm going to get the integral of cotangent of x. Remember, codes are negative, minus the natural log of the absolute value of cosecant of x plus c. I don't know what color I made this. All right, so two more 3x5 cards. There's your rules. All right, so now you know how to integrate cosine, sine, tangent, and cotangent. We'll learn how to integrate secant and cosecant soon. All right, any questions about that so far? So those are integrals that involve logarithms. So now we want to talk about integrals that involve exponentials. And in order to do that, I want to review exponential derivatives. So remember the exponential function derivative with respect to x of e to the x is just e to the x. It's the only function whose derivative is equal to itself, the only function whose integral is also equal to itself. Okay, And then the derivative with respect to u of e to the u is e to the u. Nope, that's not what I want. I want e to the u of x is e to the u of x du dx. Okay. And then the derivative with respect to x of a to the x is a to the x. And oh, it froze. Whoa, not good. Okay, so here we go. All right. And so the derivative with respect to x of a to the u of x was a to the u of x natural log a du dx. Oh, this one forgot the natural log a. That's where I was when it stopped. Okay. All righty, so those are the derivatives. So we're going to use this information to go backwards. All right, so to go backwards, if we have the integral of e to the x, we're going to get e to the x. If I have e to the u and its derivative is sitting right there, I'm going to go back to e to the u. If I have a to the x, I'm going to go back to a to the x, but I'm going to divide by the natural log. So we get these formulas right here. So the integral involving the exponential function, the integral of e to the x dx is just e to the x. And the integral of e to the u du, provided its derivative du is sitting right next to it, is just e to the u. And then the integral of a to the x dx is now a to the x, but we're going to divide by the natural log of a. And the integral of a to the u du, again, we're still going to divide by the natural log of a. Okay, you guys ready for this? All right. All right, examples. All right, the integral of e to the r dr. Well, that's just going to be e to the r plus a constant because the variable is r. So that works out nicely. I don't stress about that. If it was e to the t dt, it would just be e to the t. All right. The integral of 4 to the x dx is going to be 4 to the x, but I'm going to divide by the natural log of 4 plus a constant. Number 3, the integral of e to the 6x dx. All right, now notice I've gone from a variable to a function of a variable. So I went from r and x to now I have a function. So now I have a function here. So that's not just x anymore, it's 6x. So we're going to let u be 6x. And then du, nice and easy, is 6 dx. But I don't have 6 dx in my problem. I only have dx. So therefore du over 6 or 1/6 du becomes dx. Okay, any questions in that one line? Because I think that's where people get stuck. Identifying u, finding du, and then swapping out what's left in the problem. Okay, you guys seem all right with it.
I have a question.
Yes.
Can you go over how to find du again?
Oh, the derivative of 6x?
Oh, so that's what that is, e to the u, and then du is just the derivative of 6x.
Oh, see, you trying to make it hard. We ain't got to the e part yet. I'm just dealing with the u. See, I'm trying to take a hard problem and make it look like any one of these.
Mhm.
So notice this is just x and that's just u. It's not 2u, it's not log of u, it's not e to the u, it's just x, just simple variables. So in order to do that, I'm doing the same thing here. So if I can get this to look like e to the u du, I know the integral of that.
Okay,
So I'm going to take u and make it 6x because that's the hard part. That's the part that's keeping me from doing the integral straight. I have to deal with that 6. So therefore, I'm just taking u to be, because if I do e to the 6x, I'm stuck again.
okay.
Yes, so I'm trying to integrate e to the 6x. If u is e to the 6x, I'm still stuck. So u can only be the 6x piece
Because it's a complete function, right?
because it's a function of x, exactly.
Okay,
Okay. Lawrence, do you get the du over 6 is equal to dx?
yes.
Okay, good. All right, so this becomes the integral now, e to the u, and dx is du over 6. So you can pull the 1/6 out and get the integral of e to the u du, but that's one we just learned. That one's easy, it's right here. The integral of e to the u du is just e to the u plus a constant. So this becomes 1 over 6 e to the u plus a constant. But u is 6x. So this is 1 over 6 e to the 6x plus a constant. So there's my answer. Okay. Okay. 5x squared e to the x cubed minus 2 dx.
It's x cubed minus 2 du.
That is. So I'm gonna give you a few seconds to finish this problem. Let me know if you're stuck.
I think I'm stuck.
Who's stuck?
It's John.
Okay, where are you stuck?
Let me see. I got to the 1/3 equals x squared to dx, and then putting it down, wouldn't it be 5? Then the integral sign e to the u.
Yeah, but you got some more work to do. That's where you're stuck. Okay, did you do your du?
Yeah, my du is 3x squared dx.
Okay, what did I tell you about constants?
Oh, you divide that by 3.
5 times the integral of x squared e to the x cubed minus 2 dx. Okay, so here we go. This is e to the u. And what's left in the problem? X squared dx.
So it'll just be left with eu. I mean,
Not quite. What is x squared dx?
oh, that's a 1/3 du.
Okay, so I think now I can handle it. So this looks like 5. The integral, that's e to the u, and x squared dx is 1/3 du. You did it. You transformed it into something we know. 5/3 the integral of e to the u du is 5/3 e to the u plus a constant. But u is x cubed minus 2.
Is this gonna be on the test?
What this we're doing now?
Yeah.
I don't think it's on test. The test went up to L'Hopital's rule, and let me see. The test went up to L'Hopital's rule, and I feel like U substitution. Okay. Okay, Danielson, where do I start? Hello, Daniel.
What was the question? Where to start?
Yep, where to start?
Okay, so first, I believe the U would just be actually. Would it be sine x?
That's right. Okay.
And du would be du would be cosine x.
cosine x what?
dx.
Dx, okay, good. What else do I have to do, Danielson?
I believe, actually,
Say that again?
I actually
I
don't
give you a
know.
hint.
I think, would you go back to the original, would you go back to the, oh, those, okay, sorry. So you would take the u of pi over 2,
Okay, so x equals
which,
pi over 2. Then u is equal to the sine of pi over 2. And what do you get?
so sine pi over 2 is 1,
Good.
and sine of 0
Okay, is 0.
it would be 0, yeah.
Okay, all right, so now keep going.
So then you can kind of rewrite the integral. The top one would be 1, bottom is 0.
Okay,
E to the sine of x. And
let's switch over to another variable.
oh,
E to the,
e to the u?
good.
No.
That's
Oh.
right. Yep, nice and easy. E to the u. Okay,
And the entire cosine stuff can be replaced with du.
D. Okay. All right. Now the
So then
integral of u is,
the integral of eu is just eu
yep.
times du dx. Actually,
Okay, nope, just so you're done. When you, because the du is sitting next to it, that
Yeah.
du is sitting next to it, so I'm already done. So now I just need to evaluate it from 0 to 1.
I thought you were at the person wait just after this matter.
So I get e to the
e
1.
to the 1, that's just e.
Mhm,
And e to the 0 is 1.
good,
So it'll be e minus 1.
and you're done.
All right.
Cool, thank you. Okay, everybody get that? All right, this one's a little more difficult. E to the square root of x over the square root of x dx. Let's see. Devin,
Yeah, I'm here.
okay, what's you?
All right, is u just going to be square root of x?
Yes. Now we need to take the derivative of that, so let's write it as something we can work with. So I'm going to write it as x to the 1/2
1/2.
power.
Okay.
So what's du?
Is that 1/2 x or 1/2
1/2 x.
dx?
Okay, dx, but what's the power of x? You subtract 1, right?
Okay. Yeah.
1/2 minus 1,
Was it just negative 1/2?
negative 1/2. Good. Okay, so now I'm going to rewrite this so you can see what it is. This is actually 1 over 2 the square root of x dx. Okay, does that look like something in our problem?
Yeah, kind of does.
It kind of does. But what's different about it?
The 2 in front.
2. So how can I get rid of the 2?
Divide by 2? Multiply by 2?
Multiply by 2. Good.
So it'd be 2 du?
2 du is equal to 1 over the square root of x dx. Okay, so you should be feeling pretty good about now, because here's 1 over the square root of x dx. So that's that. And here's u, e to the u. Okay, so can you help me finish this one up?
Yeah. So now would it be the integral, and then it would be e to the u
That's exactly right.
over
Now becomes the integral of e to the u. And what happens to dx over the square root of x? What is that on the right-hand side?
oh, is that 2 du?
That's 2 du.
Okay, that makes sense.
So this is the integral, 2 times the integral of e to the u du. Now we've beaten a dead horse here, right? Because we know that's just going to be 2 e to the u plus the constant. That's the purpose of doing these exercises. We can see what it really is, right? Okay. So I'm done. This is 2 e, u was the square root of x plus a constant. Okay. All right. I'm gonna take y'all to this next one. I'm gonna call on Benaya to do this one. Okay. Benaya, are you there? Hello.
Hello,
Hi, Benaya. How are you?
I'm doing fine.
Wonderful. Okay, let's walk through this problem, okay?
All right.
All right. So what looks like the most difficult part of this problem?
That ln x.
That ln x. So let's make that u. Okay. So now we got that u is ln x because that was the thing that was bothering us the most. Okay. So now what do I need to do? I need to find du, right?
Wouldn't that be 1 over x?
Yep. We know that. 1 over x what?
dx.
Yep. Okay, so is there anything more I need to do in this problem, or have I figured out everything? This is u. And then dx over x, well, that's here. 1 over x dx is right there. So I think we've substituted everything out, right?
Yes.
Okay, so can you finish the problem? Let's see what we get next. So we get the integral.
Of 1 over x.
Okay, the dx over x comes out. And what do I put in its place?
Du.
Du, okay. And then looks like that's in the denominator, so that's just what?
U.
U cubed. Okay, so let's write it so we can integrate it. That's u to the negative 3 du, right?
Yes.
Okay, can you integrate that for me?
It'd be integrate from that would be 1 over u cubed. Wait, u3 plus 1. That's plus 1?
Negative 3 plus 1, good. So what is that?
Oh, so it's u to the negative 2.
And then you have to divide by that, right?
Yes.
Okay. Almost done. So I have negative 1/2 u to the minus 2, so I can write that as 1 over u squared. So now we are done. 2u squared is 2 times the natural log of x squared. So now we are done.
Where do 1/2 come from?
The 1/2 came from right here. You're 1 over -2.
Oh, okay.
Yep, there it is. See it? Good question. How'd that feel? So.
So hard.
Okay. Would you say hard?
Yeah.
Oh, yeah. Okay.
Yeah, another one.
Yes. Okay. What's u for this problem?
Is it the X?
Pardon?
Is it X? Or is it no?
Atlanta X?
ln x. Is that Lawrence?
No, that was Devin.
Devin. Okay, awesome. U is natural log of x. You sounded like Lawrence for a minute. Okay, so what's du?
Just 1 over x dx.
Okay, so this is the one case where the derivative is in the denominator because its derivative is 1 over x dx. Okay. All right, Devin, what do we do?
All right, now do we do the thing with the limits, the
Yep.
e and 1?
Mm-hmm.
All right, so when x is equal to e,
Okay, so if x is equal to e, then u is equal to the natural log of e. And they're inverse functions of each other. So natural log of e is just 1.
okay.
Okay. And when x is equal to 1, u is equal to the natural log of 1. And we already said the natural log of 1 is 0.
Mhm.
Okay, you ready to flip it back in?
Yeah, I think so. All right, so hold on, can you start it off really quick? I just forgot what I was.
Okay, so the first thing we do is find u and then do du. Then we have to move the limits.
Mhm.
Okay, so now all we need to do is put everything back. So log of x, that was u, and 1 over x dx, that's du. So notice everything's shaded. We can put everything back.
Okay,
So where there's an e, what do we put for e?
1,
Good. Where there's a 1, what do we put for e?
0,
Good. Where there's a log of x, what do we put?
u,
And then for dx over x, what do we put?
du.
du. All right, now I have a nice easy integral. How do you integrate u?
Mm,
Remember, we add 1 to the exponent and divide by it.
So it'll be 0 plus 1 up top, 0 plus 1 at the bottom.
I'm not sure what you mean.
Is this the x to the n plus 1 over n plus 1?
Yes.
So
Annalise?
Plus
Oh, go
It'd
ahead.
be, oh, go ahead.
it'd be 1 plus 1.
Yeah, go ahead, Devin.
no, I wasn't saying that. I wasn't sure.
Oh, okay. So Annalise, can you help us?
It'd be u squared divided by 2.
Okay, does everybody see that, Devin?
No, I don't.
Okay, so if you were integrating x dx, you would get 1/2 x squared plus a constant, right?
Hmm.
The same thing with u. The integral of u du is 1/2 at 1 to the exponent.
Oh, okay.
Okay, and then you divide by 2 plus a c. It looks different with a u, doesn't it?
Yeah.
Okay, but it's the same property.
Okay.
All right, so that's, yeah, I know it looks different, and sometimes it kind of feels different, like I don't know what to do, but it's the same thing. The integral of u to the n is u to the n plus 1 over n plus 1. Okay, so this becomes 1/2 u squared, and it's evaluated between 0 and 1.
I have a
Okay.
question.
Yes.
So when you have a case like this where the DU is on the bottom, how do you decide where to put it?
Okay.
Like, where to put it back?
The only kind, okay, so the only places where du ends up with part of it in the derivative is if you have something like the square root of x, which is why it was in the derivative, and the other one, which is when it's 1 over x. And the only way to kind of know that it's going to be like that is to go ahead and try to figure out what your u is first and see if it works out. But those are really the only few cases. Usually du is never in the denominator. Okay, but for this one, because it's 1 over x, we don't think of it as in the denominator. We just think of it as the quantity 1 over x.
Oh, okay.
Okay, so this now becomes 1/2 1 squared minus 0 squared. And notice how we get a number. Whenever you have a definite integral, you're going to get a number. When you have an indefinite integral, you're going to get a function. Okay, any questions? Now, I need to check. I think your class is the one that's set. You know where your finals, I mean, your exam is going to be. And I'm going to put a note